Hi and welcome to today's video. In today's video, we'll be exploring how to use the vector component method of vector addition. We have a question here which reads, a bank in downtown is robbed. To elude the police, the thieves escape by helicopter, making 3 successive flights described by the following displacements. The first displacement is 20 kilometers 45 degrees south of east. Second, 33 kilometers 26 degrees north of west. And the final one, 16 kilometers 18 degrees east of south. At the end of the third flight, they are captured. In what direction should the police head to apprehend the thieves faster? Okay, let's think of it like this and understand what the question is asking us. Picture the thieves start here and they make 3 successive flights with their helicopter. One is in this direction, another is in this direction, the third is in this direction. This is their final position. For the police to apprehend the thieves faster, the police have to go straight, which means they have to know the resultant. So if we can call this the first flight that they make A, call this one B, call this one C, described by 20 kilometers 45 degrees south of east and all these other vector directions given. The police have to know the resultant in order to apprehend the thieves faster. So they go straight from, instead of following the thieves in this direction, then they go this direction, then they go this direction, they go straight from here up to the final position. And that's what we'll be finding using the vector component method. With that in mind, let's get into it. So now that we know we're looking for the resultant, the steps that we have to follow in solving this question are as follows. The first is to draw these vectors on an XY plane. So let's draw an XY plane. Now we put all these vectors, starting with the first one, 20 kilometers, 45 degrees south of east. So how do we place south of east? Well, let's draw ourselves a small compass here, where this is north, this is east, this is west, and this is south. So to get the south of east, we have to go, if this is south, we have to go 45 degrees south of east. So we go to the east line, which is also the x-axis. Then we go 45 degrees below towards the south. Then this is our 45 degrees south of east. Next, we have 33 kilometers, 26 degrees north of west. So we go to the west, which is the negative x-axis in this case, then north of west, so towards the top. We go like that, and that's 26 degrees. So it will be something like that, 26 degrees. The final one is 16 kilometers, 18 degrees east of south. Now, east of south means we go to the south line, then east of south, which is just a little to the east, but 18 degrees. So that's our vector, 18 degrees east of south. So we've gotten through the first step. Draw these vectors on an XY plane. Now let's label the 20 kilometers vector as A. We'll label this other one as B and this final one as C. So that the one with 45 degrees is A, this one with 26 degrees is B, and this other one is C. Okay. Now, next step is to draw a vector component table. In the vector component table, first column, we have to have the vectors. Then these two columns, this one has the X component, this one, the Y component, the first vector A, second vector B, third vector C, and the last column will be for the resultant. So A, B, C, and finally the resultant. We get here and we see what's the angle that we're supposed to use as theta. Remember, we measure the angles from the positive x-axis. So this one from the positive x-axis, we can say this is 360 minus 45. This angle here is 360 minus 45. That leaves us with 315, making the x component 20 cos 315. If that's the x component, the y component is 20 sine 315. Next up, B. From the positive x-axis, if we measure like this, we have to say 180 minus 26. So the second one is going to be 33 cos 154. And this one will be 33 sine 154. The last one, the angle measured from the positive x-axis all the way up to here, this is 270 degrees. So that's 270 plus 18. 270 plus 18 gives us 288. Therefore, the x component is going to be, what was the magnitude of this one? It was 16. So that would be 16 cos 288. And the y component will be 16 sine 288. Now, let's get the resultant in x. So what's going to be the value that's here? So you can plug everything here into the calculator. You say 20 cos 315 plus 33 cos 115 plus 16 cos 288. You get the x component. What do you get? Remember, calculator in degrees. Paravipa. So here we get negative 10.6. Then we do the same for the y component. 20 sine 315 plus 333 sine 154 plus 16 sine 288. Here we get negative 14.9. So we found the resultant in x, we found the resultant in y. Last step is, or the next step, is to use this formula to get the actual resultant. Since this is resultant in x, resultant in y, now we need to get the actual resultant, which is given by the formula r is equal to the square root of rx squared plus ry squared. So we take the square root. Rx is negative 10.6. Then this is squared plus negative 14.9 squared. Now, we need to also get the direction, because we need to know the direction in which the police move. So to get the direction, we use tan theta is equal to ry over rx. So tan theta is equal to ry is negative 14.9, rx is negative 10.6. This gives us 1.405. Then theta is equal to Okay, now that we have theta is equal to 54.6, the actual direction in which the police have to move, we have to look at the values of Ry and Rx. So Ry was negative 14.9, Rx was negative 10.6. We can draw ourselves a small diagram here, a small XOY plane. Now, if Ry is negative, it means that it's along this axis here. And if Rx is also negative, it means that it's along this axis. That means that the resultant R has to fall within this part. Now, the angle 54.6 degrees is this one. It's always next to the x-axis. So that's our angle 54.6. And the magnitude of this vector is 18.3 kilometers. So the actual angle, if we measure from the positive x-axis, it will be 180 plus 54.6 degrees. Now, to make the final statement, the police have to move 18.3 kilometers at 234.6 degrees from the positive x-axis. Or you can also say the police have to move with the resultant 18.3 kilometers at 54.6 degrees south of west.